The next p-value pitfall is the idea that you can't prove a negative. When you fail to reject the null hypothesis, this is not the same as proving that the null hypothesis is true. This gets a little bit confusing, but if you fail to reject the null hypothesis, all that means is you have insufficient evidence to reject the null hypothesis. It does not mean that you've proven that there's no effect, that you've proven the null hypothesis. You can't prove the null hypothesis. Here's an example. What's wrong with this statement? The author writes, there was no significant effect of treatment, p equals 0.058, so just misses statistical significance, nor treatment by velocity interaction, indicating that the treatment and control groups have the same ability to perform the task. That's the null hypothesis here, that the treatment and control groups have the same ability. We don't quite reject the null hypothesis. The p-value is not quite significant, but that doesn't tell you that the groups are the same. It just tells you that we have insufficient evidence to yet say that they're different. There's a subtle difference, but a very important difference. If the p-value is greater than 0.05, that just means we have insufficient evidence of an effect. That does not prove that we have no effect. This is best illustrated with an example. So here it was a smoking cessation trial that appeared in the literature in 2010. This study was looking at women who were afraid to quit smoking because they were afraid that they were going to gain weight. So they were called weight-concerned women smoking. They were randomly assigned to one of 4 groups. They were either given a weight-focused counseling to help them quit smoking or a standard counseling. Some of the groups also received a drug, bupropion, and other groups received a placebo. So you could either get in weight-focused or standard counseling, and you could either get the drug or the placebo. The outcome was biochemically confirmed smoking abstinence. And here's the results of this study. This is a large table, and there's a lot going on here. I'm going to help you to navigate your way through this table by zeroing in on some things I want you to pay attention to. First of all, it's showing here the 4 groups, weight-focused and standard counseling with drug or no drug with placebo. There's 3 outcomes here. At 3 months, 6 months, and 12 months, it's showing you what percent of people in each of those groups had biochemically confirmed abstinence. That is, you measure like their blood, and you can't find any traces of smoking. Let's focus in on some specific data from this table. First of all, if you look at the placebo groups in the weight-focused counseling and the standard counseling groups, what do you notice about the rates of abstinence? They're very similar. They're almost identical, actually. What does this tell you? This tells you that the counseling methods appear equally effective. So if you don't combine the counseling with any drug, the counseling methods seem to have just about the same amount of effectiveness in terms of smoking cessation. Those numbers are really, really close. If we then zero in on the weight-focused counseling group, did the drug here improve quitting rates? And it's pretty clear that the drug improves quitting rates in the weight-focused counseling group, right? The rates go from 18% to 41%, 11% to 34%, 8% to 24%. They're more than doubled the quitting rates if you add the drug. And the p-values comparing the drug versus the placebo within that weight-focused counseling group were highly statistically significant. So pretty clear that the drug works in the weight-focused counseling group. What about, however, in the standard counseling group? What conclusion should we draw here? Notice that the drug does seem to improve the quitting rates. They go up quite a bit, in some cases more than double, but the p-values comparing the drug to the placebo in the standard counseling group don't quite make statistical significance. What are we to conclude? Well, here's what some of the authors and media coverage's conclusions were. So they concluded that among the women who received standard counseling, bupropion, that's the drug, did not appear to improve quit rates or time to relapse. For the women who received standard counseling, taking bupropion didn't seem to make a difference. In other words, the authors as well as the media were concluding adding the drug when you have standard counseling doesn't work at all. No effect, doesn't help. But wait a minute, let's go back to the data again. That's not quite right, right? Let's look at the data again. Actually, adding the drug pretty dramatically increases the quit rates, in some cases doubling the quit rates. The p-values don't quite make statistical significance, but should we conclude from this result that the drug has no effect in the standard counseling group? Clearly not. We might not quite be totally confident that that what we're seeing here isn't just chance, but there really looks like that there is an effect of the drug here. It just misses statistical significance. So it's clearly not proof of no effect of the drug here. And I kind of went a little further with these data and was curious and did a little bit more analysis. And what we can show, if you do some more analysis on this data, is that the drug improves quitting rates over counseling alone. That's the main take-home message that you should get from the data in the study. So I combined the data into one big set of data and ran some analyses, and I can show that the main effect for drug is significant. In other words, adding the drug to counseling helps. The main effect for counseling type was not significant. In other words, it didn't matter whether you were in weight-concerned counseling or standard counseling. We saw that those rates in the placebo group for that type of counseling were almost the same, so there was no main effect for counseling. I then looked at something called interaction, and interaction is a topic we're going to get to in the next couple of weeks. But the interaction between drug and counseling type is also not significant. And what that tells you is that it didn't matter. It wasn't that the drug only worked in the weight-concerned group. In fact, the drug overall worked, and it didn't, when its effect, we had no proof that its effect differed by counseling type. And that was one of the implications that the authors in the media coverage implied, that the drug only works in the weight-concerned counseling group. And that, in fact, is not correct. That interaction is not significant. It's just a little aside here. I'm going to talk a little bit further about interaction just to put it in the back of your head, because it's relevant in this particular example, and it's something we're going to encounter coming up in the course. So if you want to take a minute here and just think a little bit further about interaction and put it in the back of your head, I'm going to introduce the concept now. So what is interaction? What do I mean when I say interaction? If you have an interaction, that means that the treatment effect differs significantly in different subgroups. So if you had interaction here, that would mean that we could prove that the effect of the drug in the weight-focused counseling group was better than the effect of the drug in the standard counseling group. In fact, when I ran that test, when I ran that interaction test, that is not a significant difference. To prove interaction, you actually have to compare the treatment effect in the weight-focused counseling group to the treatment effect in the standard counseling group. We have to compare those between group effects. We don't compare the p-values between the groups. You don't compare the 0.07 and 0.08 and 0.05 to the 0.001 and 0.005 and 0.006. So it turns out that the drug effect was significant in the weight-focused counseling group. We saw that, but not quite significant in the standard counseling group. But that is not proof of interaction. To test for interaction, I had to run another test where I compared the drug effect in the weight-focused counseling group to the drug effect in the standard counseling group, and those were clearly not significant. And I'll show you that here again, just to set up the idea of interaction. Does the effect of the drug, bupropion, differ in the weight-focused group versus the standard counseling group? Here are the p-values, 0.4, 0.39, 0.79 for the different time periods. Clearly, we cannot say that the effect of the drug differs according to which counseling group you're in. So we say that there is no interaction here. We have no proof of interaction. So that's the concept of interaction, something that's coming up in the next couple of weeks, just to put it in the back of your head. Take-home points here. Most statistical tests are designed to disprove the null hypothesis. They are not designed to prove it. So you don't want to conclude when your p-value is not statistically significant, you don't want to conclude that that's a proof of no effect. If you want to prove that something doesn't have an effect, or that two groups are not different, if you kind of want to prove the null, you're going to need to run an entirely different type of study, something called a non-inferiority trial or an equivalence trial. That's a topic for another day, but that's the only way that you can really, at the end of a study, conclude that two groups don't differ.